Prove that integral 0 to pi d theta a plus cos of theta whole squared is equal to pi upon a squared minus 1 whole raised to power 3 upon 2, a is greater than 1. Solution: let I is equal to 0 to pi d theta over a plus cos of theta whole square is equal to 1 upon 2 integral 0 to 2 pi d theta over a plus cos of theta whole square is equal to 1 upon 2 integral 0 to 2 pi d theta square bracket starts a plus bracket starts e iota theta plus e raised to power minus iota theta over 2 bracket close square bracket close whole raised to power 2. Now putting e iota theta equal to z, so iota e raised to power iota theta d theta is equal to dz. D theta is equal to e iota e raised to iota theta को क्रॉस मल्टीप्लाई कर लिया, दिस टर्म इक्वल टू विच इम्प्लॉइज डी थीटा इज इक्वल टू डी जेड ओवर आइटा e raised to power iota theta. Since we know e raised to power iota theta is equal to z, so is equal to dz over iota z. So I is equal to 1 upon 2 integral over c dz square bracket starts a plus 1 upon 2 bracket starts z plus 1 upon z square bracket close square bracket close whole raised to power 2 iota z is equal to 1 upon 2 iota integral over c 4 z dz bracket over bracket starts 2az plus z square plus 1 bracket close whole square is equal to 4 iota 4 upon 2 iota integral over c z dz bracket starts z square plus 2az plus 1 bracket close whole square is equal to 2 over iota integral over c z dz square bracket starts z minus alpha bracket close z minus beta square bracket close whole square, where alpha is equal to minus 2a plus square root of 4a square minus 4 upon 2 is equal to minus 2a plus square root of 4 bracket starts a square minus 1 bracket close upon 2 is equal to minus 2a plus 2 square root of a square minus 1 upon 2 is equal to minus a 2 cancel out minus a plus square root of a square minus 1 and beta is equal to minus a minus square root of a square minus 1. Hence f of z is equal to 2z iota z minus alpha whole square z minus beta whole square. Poles of f of z are given by z minus alpha square z minus beta square is equal to 0. So z is equal to alpha and z is equal to beta are the poles of each of the order of 2. Since modulus of beta is greater than 1 and modulus of alpha beta is equal to 1, so that modulus of alpha is less than 1, hence alpha is the only pole of the order of 2 within C. So residue at the double poles z is equal to alpha is equal to square bracket starts d over dz into 2z over iota z minus beta whole square square bracket close z is equal to alpha is equal to 2 over iota square bracket starts z minus beta whole square into 1 minus z into 2 into z minus beta over z minus beta raised to power 4 is equal to minus 4 upon iota square bracket starts minus a plus square root of a square minus 1 plus a plus square root of a square minus 1 square bracket close whole cube is equal to 2 upon iota square bracket starts z minus beta square minus 2z z minus beta over z minus beta raised to power 4 square bracket close z is equal to alpha 2 upon iota square bracket starts z minus beta bracket starts z minus beta minus 2z bracket close upon z minus beta raised to power 4 square bracket close z is equal to alpha. This z minus beta will cancel out with this z minus beta, so here remain z minus beta raised to power 3 and z minus 2z is equal to minus z and minus beta, so 2 iota minus z minus beta over z minus beta's cube square bracket close z is equal to alpha. Taking minus common, so minus 2 upon iota z plus beta over z minus beta cube z is equal to alpha, so minus 2 upon iota in place of z alpha plus beta alpha minus beta cube, so equals to minus 2 upon iota square bracket starts minus a plus square root of a square minus 1 minus a square root of a square minus 1 upon bracket starts minus a plus square root of a square minus 1 plus a plus square root of a square minus 1 whole cube is equal to minus 2 upon iota square root of a square minus 1 square root of a square minus 1 cancel out, so we remained minus a into minus a plus minus a minus minus plus 2 minus 2a upon minus a plus a cancel out, and this term is equal to 2 times square root of a square minus 1 whole cube is equal to 4a upon iota into 1 upon 8 into a square minus 1 raised to power 3 upon 2 is equal to a upon 2 iota a square minus 1 raised to power 3 upon 2. Hence by Cauchy's residue theorem, I of 2 pi is the sum of residue within C, so 2 pi iota a upon 2 iota a square minus 1 raised to power 3 upon 2 is equal to pi upon a square minus 1 raised to power 3 upon 2. Hence integral 0 to pi d theta a plus cos of theta whole square is equal to pi upon a square minus 1 raised to power 3 upon 2.